Okay, so govern tables. The whole idea about govern tables is these main viewpoints: supporting streaming updates, deletes, and updates from your data lakes, database replication, and privacy regulations. This is achieving fine-grained data access, so column, table, row. I think I mentioned cell. I can't remember if cell is actually allowed here. And then optimization of data. So there is a feature in govern tables where it allows for automatic compaction of data objects. So if you've used glue tables, external tables, and you've been using Athena and S3 objects, you might understand that all of your data is sitting on S3. And your data might sit in one or many data objects. So if you think of a simple use case, you might have a CSV. Your table might actually consist of multiple CSV files. In some instances, it might be just one CSV file corresponds to one external table in Athena. That might not always be the case. There might be instances where your table, which you can see in Athena, corresponds to millions of individual CSV files, and they might all contain like an individual record. So that's not really very optimal, where Athena has to download all the 1 million files, then open it up, extract the data, and then close it, and then do that a million times. So it's not very efficient. It'd be nicer if there was a way to compress all of those records. So if you had a million records or a million files, is it possible to condense that all into a single file instead of having a million files? So that's one of the features of govern tables. It has the ability to automatically compress or compact your multiple files into less files at the data object level on S3. So I won't actually go into great detail on what this example does, but this one is getting started with govern tables. I'll just quickly mention what it's actually doing. So the first bit is a CloudFormation stack. The CloudFormation stack is just here to help you set up your lake formation environment. So it sets up a admin user, a data analyst user, it sets up a bucket, and then sets up the lake formation service itself. So you've got your admin user, and what happens is you've got lake formation on your AWS account. You need to actually assign an administrator user to the lake formation service on your account. So what happens is you create your user, you create your admin user, you've assigned the admin user to be the administrator of your lake formation service. Then also you start to register locations. So as I mentioned in the previous session, you register data lake locations. So the simplest example would be S3 bucket. So we've created a data lake bucket here in this CloudFormation stack. And what would happen is you've now got your lake formation service. You've set up the administrator, which is a new role that you've just created, and you've got an S3 bucket. So you're registering your S3 bucket in your lake formation service, saying, hey, this is a place where lake formation has access to retrieve data from. And then your data analyst user might have only read access. So it might have read access to the data that's on your S3 bucket via lake formation, but it doesn't have access to update any of the data there. Okay. So this process here, they're just showing you the web interface and the process of creating a govern table. At the moment, govern tables isn't a feature that's available in all regions. It's available in I think, less than 10 regions right now. Sydney is not listed as one of the available regions. So here they are just showing you what needs to be done. They've set up the data structure. So it's got marketplace, customer ID, review ID. They set it as a parquet structure. And I'm just going to skip all of this. But the main point that they wanted to demonstrate was how do you add data to your govern table? So in this example, they're showing you via the command line interface. So if you were to run this command, AWS Lake Formation start transaction, so that's saying, I want a new transaction, as in I want a new piece of work, or what I'm doing is I want to update or insert records to a new table. Now, can you please give me a transaction number to register all of my activity against, right? So I've got a transaction number, it returns a transaction ID back to me. Then I use that transaction ID to submit my data in. Okay. Okay, so this bit, they are just looking at what the data looks like. API head, data object. Okay, so just trying to see what's in the object. In this here, now they are writing a JSON object, okay? They're writing a JSON object, and then it's in this section that they're submitting. So AWS Lake Formation update table objects database name. So they're specifying the Lake Formation database that they've just created. That was created up above in the CloudFormation template. They're setting the name, and here they're using the transaction ID. So up here, we received a transaction ID. So if we ran this code, we would get a different transaction ID. We used the transaction ID that we received, would paste that into here, and would run this code. And what this code does is it's a command line interface command saying, hey, let's take the data that we have on our local hard drive. Let's insert that into the govern table, and I'm going to flag this as this specific transaction. And then, what are they doing? They're actually just pulling back. Okay, so they're just pulling back the objects that were registered with Lake Formation govern table. So if it was successful, if this command was successful and it was successfully inserted into your table, then you'd see it here. Now, if this was unsuccessful, then this whole transaction would fail and then roll back to the previous state. So I guess this is just a way to manage the inserting and updating of records and managing everything via transactions. Okay, I won't go into this in any great detail because I didn't think it was that helpful. The next one, which was part 2. So part 2, creating govern table for streaming data sources. There's actually 5 parts to this data lakes and govern tables. So this shows you how it's all hanging together in this specific solution. So what we have is CloudTrail. So CloudTrail is simply a log of all of the AWS activities that are happening on your account. So you have an AWS account, right? And in that account, you've got thousands of different services. So for example, one of the common ones, Lambda, IAM, and S3 buckets, right? So let's say if you go into your AWS Web Console, you go to the S3 console page and you list out all of the, let's say 50 bucket names that you have on your account. Now that activity of performing the list, or basically your web browser has asked AWS, give me all of the buckets that are currently on my account, and then your AWS account, depending on your level of access, will provide that or deny it. Now that kind of activity, those API calls are all captured in CloudTrail. So the fact that you've asked for a list of all of the buckets, that has been captured in CloudTrail. So if you were to go into Lambda and then list all the Lambda functions, that also would get captured in CloudTrail. If you was to say create a new Lambda function, that gets captured. And if you were to delete a S3 bucket, that also gets captured in CloudTrail. So it's just a log of all of the activities that are happening on AWS. Now, all of those activities are actually mirrored into the Amazon Event Bridge. So Event Bridge is a bus system. So it works like ESB, so Enterprise Service Bus, where all messages are just dumped onto that bus and you can use them or not use them. But what's special is CloudTrail has a specific, bus where all activity that's happening on your account is also mirrored on EventBridge, on the AWS EventBridge bus. You can create custom buses, but in this example, we're just using the default AWS EventBridge bus. And then we are using an EventBridge rule to filter out for these events that are happening on our account, and simply let's just take all of the activities that are happening on our AWS account and then pass them into a Kinesis data stream. So Kinesis data stream is there to capture streaming data, and it's there to capture streaming data in such a way that it like acts as a cache, right? You might have tens of updates or millions of updates coming in to your Kinesis data stream, but you can't continually process them. So what happens is you have your Kinesis data stream, which will cache it, and you'll have your cache there, and then you'll have another glue streaming job, which will look over a cache and incrementally run micro batch jobs over your cache in Kinesis. So this glue streaming job basically runs all the time, looks at Kinesis data streams, and slowly pulls out records. Let's say it pulls out 100 records at a time, processes all of that data, and then dumps the resulting data onto S3. Okay. Then we have our lake formation. So lake formation is, again, using govern tables. It's managing all of the data that's coming into S3, managing all the permissions and access, and managing the different versions of govern tables. So in the previous session, I mentioned that all of the updates are performed by transactions. So what happens is, let's say we get 1,000 new events coming from CloudTrail that get mirrored into EventBridge. Now, because of our rule is a catch-all for everything, those 1,000 events get dumped into the Kinesis data stream, and then we've got a glue streaming job. Let's just say it picks up 100 of those records at a time. It processes those 100 records and then dumps the resulting processed data onto S3. Now, when it does that, it creates that object, but also kind of registers that new object as part of the govern table. So going back, it creates a new transaction saying, hey, I want to insert these new 100 records into my govern table. Give me a transaction ID. Lake formation will give a transaction ID. Glue will attempt to insert or update with those 100 records. And if successful, then govern table will now have access to those 100 records. And then you can use Athena to read those updated records. Now, because you've got governed tables, then you have the ability to also step back in time. So if you wanted to see what was the state of the governed table yesterday, or what was it a week ago, or what is it now, all of those states are managed automatically in governed tables. Okay, now to this example. Here we've got the same sort of thing. This CloudFormation template, as it says, it's creating a Lambda function, it's creating a S3 bucket, IAM roles, lake formation settings, it's got a Kinesis data stream, it's got event bridge, and it's got the glue job. So if you were to deploy all of these things, which I just previously did on this page, then you'd have your deployed solution. What I've done here is, this is a CDK version of the template. We can grab a copy of the template. So if you look, it's normally just a S3 object that's made available. So this is what it looks like. This is a CloudFormation template. You've got parameters, you've got metadata, and you've got your resources. So one of those main things was the S3 bucket. So this is all written in YAML. But here, this is the Python version. So this is CDK, and here is the equivalent S3 bucket defined here. Okay. So what I've actually done, I've taken this whole solution and I've translated into CDK. CDK will actually translate it back into this solution. But anyway, so I just did that so I understood what was actually happening. Let's go back. This page. So it's created all those kind of things. This attempts to guide you through a process of creating the govern table. I have already defined the govern table as part of my solution. No, wrong script. Yep. So here I've got the govern table. It's a glue table. I've just called it govern table. That's got a S3 location and I can't remember. And there's just an entry here saying this table type is governed. Okay, so I've already done all of these manual steps through the CDK template. So that goes through all of this. It goes through the process of setting up all the permissions. So in the previous session, I covered off on how lake formation manages a separate table of permissions. And that was here. So this has all been set up. Then we come back to here. So that's all the permissions. And then it talks about adding data to your govern table. So remember in the previous example down here, we retrieved a transaction and then we ran this AWS Lake Formation update table objects. We basically registered a new object into a table. Now for this example, it's slightly different in that what we have is we've got actually a glue streaming job. So here we've got a glue streaming ingestion job, and I might as well run this while I'm here. So this is a Spark streaming job. It's written in Python. And what this does is, let's go back to that little diagram. You've got a CloudTrail. That dumps everything onto the event bridge, everything gets dumped onto the Kinesis data stream. Now, in between Kinesis and Glue, in between here is actually a Glue table. So I didn't actually realize this previously, but Glue table, in addition to, I guess, fronting S3 data objects, you can actually use Glue tables to front Kinesis data streams. So the Glue table acts as another layer to parse the data. So the raw data from Kinesis data streams gets passed via the Glue table, and the Glue streaming job will understand how to, I guess, parse and interpret the data that's sitting on the Kinesis data streams because it's going via that Glue table. Okay, so coming back here, so this job now, it's starting up. It's a little, basically in the background, there's a little virtual machine that gets spun up. It's going to run your Python jobs. It's accessing the data via the Glue table. The Glue table is fronting the Kinesis data stream. I think I didn't open. Okay, here's the code. Okay, and here is the Glue job code. So what it does, it's got a whole section here for mapping. So mapping the raw data payload into the new destination table. And then it's got a section here for if you've got everything in a data frame, then it's basically creating a new transaction and committing that transaction to your govern table. So this whole Glue job, instead of running the CLI command to update your govern table, as part of this Glue job, it will actually register those new records from the stream into your govern table. Okay, so this one should be still running. So because this is a Glue streaming job, you don't actually you can always leave it running. It keeps a checkpoint of where it's up to and where it needs to pick up from. So you can leave it running the whole time, or you can probably stop it and start it because it should know where the last record that it did process. But if you want it to run 24/7, you can run it 24/7. Then you'll always have continual updates into your S3 bucket, which means you'll always have access in your govern tables. Okay, so now that we've got our Glue streaming job, right? So let's just go back. I accidentally closed it. Okay, so we've got CloudTrail events, all of them fitting to Event Bridge, all of them fitting into Kinesis data streams, and then all of them feeding into the Glue streaming job. Glue streaming job is processing all of that data and then just flattening all of those records at the moment. And it's doing that in micro batches. Then it's dumping all of that data into S3 and registering that new data into the govern table. And then coming back over to Athena. I think I had a query set up previously, but anyway. So one thing when using govern table, you need to make sure that you use a different work group called Amazon Athena lake formation. And then coming back to here, we've got our CloudTrail database. We've got our govern table. And this one has a few attributes and different partitions. And I'll just show you querying it, and then I'll show you the ability to, I guess, step back in time. Okay, so what if I event time? Okay, so all I'm showing here is if we were to just retrieve the latest 10 records, what does that look like? Okay, so we've got 245. And then I think they had an example. My screen went a bit weird. They had an example here. Let's say you wanted to get a previous version from 5 minutes ago. I don't know if it's been running for that long. Let's drop it down to 2 minutes. So before we had 245 come up. And here we've got 243 as the latest transaction. So you can see that here you can just change the version of the table that you would like to query against. I don't know if you can, I don't think we've been running it that long. It should come as nothing then, possibly. Yep, okay. So because we haven't been running the glue job for long enough, it hasn't captured data before 10 minutes ago. Yeah, so this whole session, just to really go over govern tables, streaming, how a glue streaming job would operate, how it actually interacts with Kinesis, and it actually interacts with Kinesis via a glue table in between to do the, I guess, parsing of the data. And then also part of the glue streaming job, it both loads the data into S3 and also registers that new data in the govern table. And then we saw in Athena how we can query that data and the ability to query current state and also prior state. So it's kind of like type 2, but it's slightly different in that the syntax is slightly different. All right, I'll leave it there and we'll continue on to the next session next time. I think that might be part 3. ACID transactions for on-govern tables. All right. Anyway, that's it. Thanks.